Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 7 Integrals Exercise 7.2. Already in the last videos, in the Exercise 7.2, we have seen the solutions up to 31st sum. Now we are going to see the solution of 32nd one. 32nd one, what is the given function? 1 by 1 plus cot x. So we can write it in terms of integration 1 by 1 plus cot x. So, integral 1 by 1 plus cot x dx. So, this function, it's not in the standard form. So, it is direct integration formula we don't have for this function. So, we have to do some simplification or some formula substitution we have to do. So, simplification, of course, we can't proceed. So, what we can do is cot x, I am going to rewrite in the form of cos x by sin x. So, 1 by 1 plus cos x by sin x. Now for the denominator part alone, I am going to take LCM. So when we take LCM, 1 by, here what happens, if 1 we can write it in the form of sin x is the LCM. So we can multiply and divide by the sin x plus cos x by sin x. Now since denominator is same, so this one sin x cos x we can combine and write. So integral 1 by sin x plus cos x by cos x. Sorry, by sin x. The common denominator is sin x. So by sin x dx. Denominator, the sin x we can carry to numerator. So this one becomes integral sin x by sin x plus cos x. Okay, so the given function, this is the given function 1 by 1 plus cot x. So the given function we change to this model. But now we will notice whether it is in standard form, direct integration we can able to do it or not, so that we can check. So in integration formula, the direct sin x by sin x plus cos x, we don't have formula for that. So further we need to do something. We have to bring it into standard form. Sin x differentiation is what? Cos x, that we don't see in the numerator. Cos x differentiation sin x. Sin x we have. So what we can do is we can add, okay, we can add 1 cos x, and we can, for balancing purpose, we can subtract 1 cos x. But if you notice, see, sin x plus cos x for balancing minus cos x we can write it. So sin x plus cos x. So the sin x differentiation is cos x that we have. Cos x differentiation minus sin x. So here we will write it like minus of minus. This way we can write down. But thing is, what about this cos x? This cos x will be left as it is. So what we are going to do is, one more sin x if we have, then we can combine with that. For that purpose, I am going to multiply and divide by the 2 first. Here, I am going to multiply and divide by the 2. The numerator 2, I am going to combine with the to the sin x. And denominator 2 constant term, I am going to take it outside. This denominator 2, I am not going to use, so I have taken it as outside. Numerator alone, it's a 2 sin x by sin x plus cos x. So numerator, how many sin we have? Sin x plus sin x. So 2 sin x we have over there. So this 2 sin x is what? 2 times of sin x we have. That is sin x plus sin x. And as I told before, we have cos x, right? Sin x differentiation is cos x. No. So I am going to add 1 cos x, and for balancing, and I am going to subtract 1 cos x. So now sin x plus cos x. Now I am going to change the order. So this sin x and plus cos x together, changing only the order. Okay, sin x plus cos x, and next this sin x minus cos x. I just shifted these two terms. Next by sin x plus cos x. Totally in numerator we have 4 terms. For all the 4 terms, this denominator sin x plus cos x is common. But what I am going to do is, two terms I am going to consider as a one term. Okay. So now I am going to write a sin x plus cos x denominator for both the terms separately. So 1 by 2 integral sin x plus cos x by sin x plus cos x. Same way for the next term, plus sin x minus cos x by sin x plus cos x dx. Now this term will get cancelled. Now what we have? 1 by 2 integral 1 plus sin x minus cos x by sin x plus cos x dx. Integration is applicable for 1 as well as for this term. The 1 by 2. Even this 1 by 2 also common for both the terms. So integral 1 by 2 integral 1 dx plus 1 by 2 integral sin x minus cos x minus cos x by sin x plus cos x plus cos x dx. So this one, so basically this is the question. Integral 1 by 1 plus cot x dx. So this one only we change to this way now. So what is that? Integral 1 by 1 plus cot x. So this is equal to this particular part. So now I will name this as a equation 1. Now first part alone I will consider integral 1 dx. So that part I am going to do the integration. Integral 1 dx. So integral 1 dx is what? When it is 1, I told we need to take it as a x power 0. Then x power n formula we need to apply. So what we will get? Integral 1 dx, we will get it as a x. Since we have a 2 terms, so for this one as a C1 I am going to consider. And now next part integration. Next part what we have? Integral sin x minus cos x by sin x plus cos x dx. Okay. Sin x differentiation is what? Cos x. Cos x we have, but it is in terms of negative. And cos x cos x differentiation is what? Minus sin x. So that is in terms of positive we have. So what we can do is, I am going to take minus sign commonly outside for the numerator term. So when we take minus sign outside, positive term becomes negative and negative term becomes positive. This way it will change by sin x plus cos x dx. This minus sign we can carry outside. Now this part sin x plus cos x differentiation only we have in numerator. See, sin x differentiation cos x differentiation minus sin x we have in numerator, right? So now this one sin x plus cos x we can consider as a t. So let t equal to sin x plus cos x and dt is sin x differentiation cos x differentiation dx. Cos x differentiation minus sin x differentiation dx. Now dx we can take it outside commonly. Yes, we got the numerator term, right? Only the order is getting changed. So same term only this one. So now we can substitute here. So cos x minus sin x dx is what? It's a dt. So dt and sin x plus cos x is t. So 1 by t. So now we got it in the standard form. So integral 1 by x dx is what? Log modulus of x. So log modulus of t plus c. What is the t that considered? Sin x plus cos x. So we need to substitute t as a sin x plus cos x. So what is that formula we used? We have a standard form. Integral 1 by x dx is log modulus of x plus c. Here in terms of t we have So in terms of t itself, we return the integration also. And for our convenient only, the x function in terms of t we changed. So after integration, we need to substitute it back in terms of x itself. Okay. And two parts actually we have, right? So this one as a C1 we have taken. So this constant as a C2. Now in equation 1 we will substitute. In equation 1 what is the left hand side? Given question, right? So integral 1 by 1 plus cot x dx equal to, in equation 1, 1 by 2. So 1 by 2 will write down as it is. And then integral 1 dx. Integral 1 dx value is what? X plus C1. X plus C1. And then 1 by 2 plus 1 by 2 into integral this part. So this part result only this minus log modulus of sin x plus cos x modulus close plus C2. This minus sign we can combine here. So 1 by 2x plus C1 minus 1 by 2 log modulus of sin x plus cos x plus C2. Okay, so C1 and C2 both are constants. When we combine both the constant, again it's going to be a one constant only. So 1 by 2x minus 1 by 2 log modulus sin x plus cos x. See, when two numbers, if it gets added, the result will be another number. That number only I am naming it as a C. So C1, C2 together, we can put 1C. If we want, now we can take 1 by 2 commonly outside. So x minus log modulus sin x plus cos x modulus, bracket close plus C. So that's all the solution of the 32nd sum. So what we done? First we noticed that whether given function is in standard form or not. So it is not in the standard form. So cot x, what we done? Cot x we changed it as a cos x by sin x. So after that we taken LCM here. And once we taken the LCM, we got the same denominator. And we combined both the sin x plus cos x here. And denominator we taken to numerator. And then we noticed whether differentiation of the denominator function are we getting in the numerator. We are not getting. So some alternatives we have done here. So multiplied and divided by the 2. And only numerator 2 we considered. Denominator 2 we taken outside. Since we are not using that, we have taken outside. And 2 sin x only we written in the form of sin x plus sin x. And purposely what we done? Cos x added and subtracted the cos x. Next sin x plus cos x together we considered one term. Sin x minus cos x as another term we considered. After that, this denominator separately we split it and we written. So this term, same terms, it will get cancelled. And this is the second term. Integration applicable for both the terms that we consider as a equation 1. And now this part separately integration we proceeded. And for this part separately integration we proceeded. Okay. And then integral 1 dx is what? Only x. Okay. So I told many times that in the last videos, integral means antiderivative. So antiderivative and derivative cancel. What is the left out one? Only the x. Otherwise, using x power n formula, 1 we can take it as x power 0. Even using that x power n formula, when we apply the integration, we'll get the same x only. Okay, so integral 1 dx is x. Since we have two terms, for the first term integration, I taken constant as a C1. Now second term integration. So denominator's part, differentiation only we have in numerator. So denominator 1, I consider as a t. And using that integration by substitution, we done the integration here. Then both the results in equation 1 we substituted and constants together I combined and named it as a C. Okay, so next we can move on to 33rd. Yes, 30. This one 32. Next we can move on to 33 sum. This 33rd sum also, Like the same model, like 30-second how we done, the same process only we need to proceed. But we have a tan x, here we have cot x. Cot x what we done? Cos x by sin x we written. So here sin x by cos x we can rewrite, and the same process we can proceed this one. So given integral 1 by 1 minus tan x dx. So that is the given function, 1 by 1 minus tan x. Now this one directly it is not in the standard form. So what we have to do? We have to do some simplification or some formula substitution. We need to bring it as a standard form to proceed the integration. So tan x, no, we can write it in the form of sin x by cos x dx. Now taking LCM, integral 1 by cos x by cos x minus sin x by cos x dx. Now we got the cos x as the same denominator. We can combine this cos x and minus sin x. So integral 1 by cos x minus sin x by cos x. Denominator is denominator, we can take it to numerator. So cos x by cos x minus sin x. Now this function only we turn to this way. This is also not in the standard form. So like previous sum what we done, we brought same cos x and minus sin x here, right? So for that purpose, first I am going to multiply and divide by the 2. After that, the denominator 2 we are not going to use. I am going to take it to outside, 1 by 2. So now numerator 2 alone combining with this cos x, writing it as a product. So cos x minus sin x dx. So this cos x is what 2 times of cos x, right? So cos x plus cos x. So 1 by 2 integral cos x plus cos x. Now here cos x differentiation is what? Minus sin x, that we don't have here. And sin x differentiation cos x, that part alone we have. So I am going to add and subtract sin x in the numerator. Equation also will be balanced. So cos x minus sin x dx. Now I am going to change the order. This cos x and minus sin x together, 1 by 2 integral first term and combining with the last term, and second term, third term writing as it is. So this denominator cos x minus sin x, okay, is common for each and every term. Totally 4 terms we have in the numerator. But what I am going to do is, I am going to consider 2 terms together. Now this denominator I am going to split and write. So integral cos x minus sin x by cos x minus sin x plus cos x plus sin x by cos x minus sin x. Integration is common for both the terms. So 1 by 2 integral, okay, this one cancel, right? So value 1. These two cancel, so 1. So integral 1 dx plus integral cos x plus sin x by cos x minus sin x dx. So integral 1 dx value what? I told many times, integral 1 dx is what? X itself. So antiderivative, derivative will get cancelled. We'll have only the x. So this one is what? The left hand side is integral 1 by 1 minus tan x. Integral 1 by 1 minus tan x dx. So this one I am going to consider as the equation 1. Now first I am going to find out the value for the first integral part. Let integral 1 dx is what? X plus 2 terms we have. So I am going to take it as a C1. Next part I am going to consider. So what is the next one? Integral cos x plus sin x by cos x minus sin x dx. Cos x differentiation is what? Cos x differentiation minus sin x. So here we have a positive sin x, and here sin x differentiation cos x, but we have a minus sign. So obviously here we need minus sign, right? So what we can do is here negative sign I am going to take commonly outside. So when we take, both the terms becomes as a negative. This way it will change. Now cos x minus sin x. This minus sign we can take it outside. So integral minus cos x minus sin x by cos x minus sin x. Okay. So denominator's term differentiation only we have in numerator. So denominator 1 I am going to consider as a t. Otherwise directly also we can write log modulus of cos x minus sin x also we can write. But we are going to use integration by substitution. So let t equal to cos x minus sin x. Cos x differentiation minus sin x, x differentiation dx. So minus sin x differentiation cos x, x differentiation dx. So dx when we take commonly outside, what we have? Sin x minus sin x minus cos x dx. That's what we have in the numerator. Now when we substitute minus integral minus cos x minus sin x into dx only, it's dt. Only order is getting changed. So that's fine. So this is dt. 1 by cos x minus sin x we taken as a t. Now it is in the standard form. Integral 1 by x dx formula is what? Log modulus of x plus c. So minus log modulus of t. Since it's a second part of the integration, you can put c2. So what is the t that we considered? Cos x minus sin x. So replacing t as a cos x minus sin x plus c2. So now we done the integration of the both the parts separately. Now in equation 1 we will substitute it. Integral 1 by 1 minus tan x dx equal to 1 by 2 bracket integral 1 dx. Integral 1 dx is what? X plus c1. X plus c1. After that integral cos x plus sin x by cos x minus sin x. So this part integration is what? Minus log modulus cos x minus sin x plus c2. So now when we take c1 and c2 together, what we will have? 1 by 2. I'm going to take it outside. So x minus log modulus cos x minus sin x. And while taking outside, this 1 by 2 also what? It's applicable for c1 and c2. So we will have 1 by 2 c1 plus 1 by 2 c2. So when two constants, when we add together, the result will be c only. So 1 by 2 x minus log modulus cos x minus sin x modulus close plus c. So that's all the solution of 33rd sum. Okay, it's like a same 32nd model. Okay, and next one, next 34th sum, we'll have a look at what is the given function. So given is root tan x by sin x into cos x. Integral root tan x by sin x into cos x. Into cos x dx. So whether it is in the standard form Obviously not. It is not in the standard form. So we have to reduce this one into the standard form. So here what I'm going to do is, I'm going to purposely multiply and divide by the cos x. So integral square root of tan x by sin x into cos x. Okay, into, now cos x, with the cos x I'm just multiplying and dividing. So now this cos x I'm going to carry to denominator's denominator. So integral square root of tan x by this cos x, under the sin x I'm going to write sin x by cos x. This cos x into cos x, it's a cos square x dx. Sin x by cos x is what? It's a tan x. So square root of tan x by sin x by cos x is tan x into cos square x dx. So here square root of tan x, and here tan x we can write it in the form of root square root of tan x into square root of tan x. So with the one square root, one will get cancelled. So one more in denominator, one more square root of tan x will be present. Square root of tan x will be present. So now this denominator cos x square we can carry to numerator. So 1 by cos square x is what? It's a secant square x dx. So the given function we turn to this way. Now if you notice, tan x differentiation is what? Secant square x. So this part differentiation only we have in numerator. Now integration by substitution we can proceed from here. So square root term, that is tan x, we can take it as a t. Let t equal to tan x. So differentiating tan x differentiation secant square x dx. When we substitute in this secant square into dx only dt. Tan x only we taken it as a t. So square root t. Now integral square root t. Square root is what? Power 1 by 2. So this power 1 by 2, if it carry to the numerator, so then in power we will have a negative sign. So t power minus 1 by 2 dt. Now using integral x power n dx formula, integral x power n dx is what? X power n plus 1 by n plus 1 plus c. So using this formula, we can integrate this term. So whatever we have for the power, we have to add plus 1. And same power we have to repeat in denominator. Since it's an indefinite integral, we need to put plus c. Now from 1, if we subtract half, one more half will be there. So 1 by 2 is what? Square root. Square root t. And denominator's denominator, we can take it to numerator, right? So this 2 will go to numerator plus c. So what is the t that we consider? Tan x. So t we can replace it as a tan x. That's all the solution of this sum. Okay, so 34th one, this is the given function. Given function is not in the standard form. So we done some alternation here. So cos x, with the cos x I multiplied and divided. So the reason is, so this root tan x, to get the tan x here, denominator cos x is required for the sign. So then when we multiply this numerator cos x, we can carry to denominator's denominator. At the same time, with the cos x, if we have one more cos x, it becomes a cos square x. So cos square x, when we carry to the numerator, it's a secant square x. 1 by cos square is secant square x. So we will be bringing this function in terms of only tan and secant function. So we can able to relate with the one function to each other with the help of derivative. Then using integration by substitution, we proceeded the integration. Okay, now we can move on to the next sum, 35th one. We'll see what is the given question. 1 plus log x whole square by x. Integral 1 plus log x whole square by x. So this function is not in the standard form. Okay, this is not in the standard form, so direct integration is not possible. Are we able to do any simplification? No. But we can see one thing here. 1 plus log x differentiation is what? 1 differentiation 0. Log x differentiation 1 by x. So we can see a denominator x over here, right? That is 1 by x we have. So this 1 plus log x we can take it as a t. Let t equal to, let t equal to 1 plus log x. Now dt is 1 differentiation 0. Log x differentiation 1 by x, x differentiation dx. So dt is 1 by x dx. Now this stuff we can substitute here. 1 plus log x is what? T. So t square. And 1 by x dx, product of 1 by x dx only dt. Now using integral x power n dx formula. If x some function rise to some numerical value, then what is the thing we need to do? X power n plus 1 by n plus 1 plus c. So as per the formula, we'll proceed this. So power is 2, we can add plus 1, and same power we can repeat in denominator and plus c. So t cube by 3 plus c. So what is the t here? 1 plus log x. So 1 plus log x whole cube by 3 plus c. So that's all the 35th sum. So next sums, 36th sum onwards, we can continue in the next video. And thanks for watching. And please do subscribe. Thank you.